with all of this, and it will make sense, okay? We're going to start with talking about proportions today and solving proportions. And those of you in here, you have this in your notes. So you're just going to follow along in your notes and fill in your notes. That should make it a lot easier than trying to write the notes all in your notebook. Okay? So my question to all of you, and those of you at home also, is, are the following statements true? Is 2/3 equal to 6/10? And is 3/4 equal to 6/8? Are those statements true? What do you guys think? What do you think? Is that true? Is the first one true?
No.
No?
No.
Okay. So I'm hearing no on that one. How about the second one?
Yes.
Okay, how do you know? How do you know if that's true or not? Okay. Got lucky? Go ahead, Maya. Cross multiply, right? We learned about cross multiplying last week. Or the week before, I'm not sure. I can't remember, I lose track. But if you cross multiply, you have 20 and 18 on the first one. Those are not equal. Okay? If you cross multiply on the second one, 24 and 24. Those are equal. Okay, so we know that the first one is no and the second one is yes. Okay, then we need to fill in this question. What is a proportion? Does anybody remember? We've talked about proportions. We should have maybe written it in our notes, but we all know that notes taking at home went really, really well. Or not. Anybody remember what a proportion is? No? Anybody at, oh, somebody at home remember, maybe remembers, no? If anybody at home remembers what a proportion is, type it in the chat. Maybe you guys at home are smarter than these guys in here, or have a better memory.
Ratios that are equivalent
What?
are said to be
Ratios that are equivalent.
Two equal ratios, okay.
that are equivalent are said to be proportionate.
So, you guys, just so you know, these guys, some of them figured out that we can look back at the notes that Miss Alford just gave us and find it. And they did, and it's two equal ratios. Okay, so a proportion is two equal ratios. So this first one was not a proportion, the second one is a proportion. Okay? All right. Then let's move on from that. We already know about cross products. Cross products in a proportion are equal. Okay, so in this first box, these are proportions because the cross products are equal. 8 times 9 is 72. 12 times 6 is 72, so they work. In this one, they both equal 30. Whoa, it's like a ghost. Okay, so if the cross products are the same, we say it's a proportion. If they're not the same, this one is 7 and 12, then they are not a proportion. 24 and 25. Okay, do we recall that? Remember learning that? Okay, then. Okay, to tell whether or what I'm asking you, and those of you at home, I want you to do the same. Tell whether the following ratios are proportional by finding the cross products. So yes or no. Either yes they are or no they're not. You guys take a minute. Example 1 and example 2. Tell if they are proportional or not. And of course, you can use your calculator.
First one's not.
Okay, write it down on your notes. Okay, I am going to remind some of you, you do have to pull your mask up and keep it up over your nose. I know that that was one benefit of being at home, is you didn't have to wear a mask every day. It was a benefit for me too because I didn't have students in my classroom. I didn't have to wear a mask every day, but we do have to get back in that habit. Okay. Brooke, your question of do we have to write this down or just listen? Write down what you think you need to. Okay. You are going to get a notes packet tomorrow. So write down whatever you think you need for homework tonight. Maybe put some examples in your notes, that type of thing. Okay, so number 1, is that a proportion? No. Okay, number 1 is no because 6 times 15 is 90 and 5 times 21 is 105. So doing those cross products, they are not equal. How about number 2? Yes. Number 2 is yes. This one I can do in my head. This is 30. 5 times 6 is also 30. Okay. Now, most of what you see today is not going to be problems like that. It's going to be word problems. Okay? I know that word problems are sometimes more difficult for you. Here we have a shade of paint is made by mixing 5 parts red paint with 6 parts of blue paint. If you mix 12 quarts of blue paint with 8 quarts of red paint, will you get the correct shade? Okay? What you need to be able to look at is what are we comparing in this problem? So anytime we're dealing with ratios, we're going to ask ourselves, what are we comparing? What is this problem about? Paint. Any specific colors of paint? Red and blue, right? We're comparing red paint to blue paint. Okay, so all of you sitting in this room right now, your pencil should be writing. Okay, I know you're not used to taking notes because when you're sitting at home, I have no way of making sure you're writing things down. Right now, you're just filling in the notes as we go. Okay, you have the notes in front of you. You just have to fill it in. We're comparing red to blue. So we need to read through this problem and figure out how much red to how much blue. And in the first sentence, it says 5 parts of red to 6 parts of blue. What number should go on top, the 5 or the 6? How do you know, Ethan? Good. We said red over blue. So the 5 stands for red. That has to go on top. The 6 stands for blue. That has to go on the bottom. So you put 5 over 6. Then it says if you mix 12 quarts of blue paint, so we have 12 quarts of blue with 8 quarts of red. Should the 12 go on the top or the bottom? Why, Maddie? Okay, Maddie said it goes on the bottom because it's blue. It says 12 quarts of blue. That means the 8 has to go on the top. And our question is, is that a proportion? Austin, you say no. Why not?
Because 12 times 5 equals 60, but 6 and 8 equals 48.
Good. So would you get the correct shade? No. Okay, because the cross products are not equal, we will not get the correct shade. Questions there? All right. Then we're going to work on solving proportions. And those of you at home, this is where you might want to write these examples down in your notebook. Okay. When we're solving proportions, you won't know one of the 4 numbers. One of the 4 numbers is missing. Okay, and so then we want to solve it to figure out that missing number. Now, I'm going to show you how to do that using cross products. And then I'm going to show you the quick way to do it. Okay? Cross products works like this. Okay, right? You multiply what's diagonal from each other. So I'm going to do 12 times 14, which is 168. And the other one is 4D. 4 times D. Now it would be our job to figure out what does D have to equal. How do I finish solving this equation to find D? Anybody remember? Riley, go ahead.
You divide it.
You divide, absolutely. Okay, this is just a one-step equation. Our goal is to get D by itself. Whoa. Okay, I want to get that letter D by itself, so I'm going to divide each side. My board is being goofy. Divide each side by 4. And so I'm going to do 168 divided by 4, and I get 42. Okay, so D equals 42. Okay, if we're solving a proportion, we're trying to figure out what does that letter equal. Now, if I put 42 into this proportion, we can check if it works. Are the cross products equal if I put 42 there? Absolutely. 14 times 12 is 168. 42 times 4 is 168. So it works. This is my answer. Okay. Now can I show you the really quick way to do this all
Yes.
in one step? So cross products always work, right? We know cross products are equal. I could do cross products, same thing on here. But here's what you're always going to end up doing. You're going to multiply the numbers on the diagonal and divide by the third number. Always. Okay? So you're going to multiply 14 times 5, which is 70, and then divide by 10. So M equals 7. Right? Anytime we're solving a proportion, you're going to multiply the two numbers on the diagonal, divide by the third number. Okay, those of you at home, does that make sense? Any questions so far? Those of you at home, if you have a question, you really just have to unmute yourself and ask. Okay, then we're going to keep going because we're going to do some word problems with this. Okay? So, I will say you're going to see some problems like this on your homework, where they're just straightforward, solve the proportion. You're also going to see a whole lot of problems that look more like this. Okay, where it's a word problem. And this one says the skull length of a crocodile is proportional to its body length. What are we comparing? From that first sentence, we can tell what we're comparing. What are we comparing, Savannah?
The skull length and the body length.
Yeah. We're comparing the skull to the body. And those of you at home, you don't have to write the whole word problem down, but maybe you just write this example down so that you have it to look back at. Of course, the notes are also posted on Canvas. Okay? So we're comparing skull to body. In one species, a 6-foot crocodile has a 2-foot skull. And it says to estimate the length of a crocodile that has a 4-foot skull. So there's my 3 numbers. I'm missing 1. Where should the 6 go? Top or bottom? Even you say bottom, why?
Because buckets the body.
Yeah, absolutely. So I decided to put the body length on the bottom. That means the 6 has to go on the bottom. Okay, the 2-foot skull, 2 goes on the top. Okay, where should the number 4 go? Where should that go, Riley?
On the top.
On the top. It's a 4-foot skull. The question is estimate the length of the crocodile. We do not know that bottom number, so I'm just going to put an X there because I don't know it. Okay, and now we're going to solve it. Okay, so anytime we solve a proportion, we're going to multiply the 2 numbers on the diagonal and divide by the third number. Grab your calculator, multiply the 2 numbers on the diagonal, divide by the third number. And you get 12. You might have been able to do that one in your head. So the length of the crocodile is 12 feet. Questions there? Okay, those of you in here that have a notes packet, flip to the next page in your note packet, which is the back side of that page. Okay, we've got 2 more problems we're going to go over. The ratio of boys to girls in a soccer league is 4 to 5. If there are 52 boys in the league, how many girls are there? What are we comparing? What's being compared, Austin?
Girls and boys.
Girls and boys. Does it matter if I say girls to boys or boys to girls? Not really, as long as we're consistent. Okay, so if I say girls to boys, we have this ratio of 4 to 5. Should I put 4 over 5 or 5 over 4? What do you think? How do you tell? Here's how you tell. Look at you guys. It says the ratio of boys to girls. It might be easier for me to flip this around. Because it said the ratio of boys to girls, I kind of want to put boys first. Okay? Because then I can put the numbers in the order that they're given. So we have 4 to 5. 4 boys for every 5 girls in the soccer league. If there are 52 boys, where should the number 52 go? On the top or the bottom? Where should it go, Riley? On the top. We put boys on the top, so 52 goes there. Now, if I would have left it flipped around like we had it, that just means everything would be flipped around. Okay, so you have to make sure you're putting your numbers in the right spot. I'm going to put X on the bottom. And now you have to solve it. How do we solve this? You can use your calculator, but what are we going to put into our calculator? Matthew, go ahead.
5 times 52 is 4.
Absolutely. Multiply the two numbers on the diagonal. So 5 times 52 is 260. And then divide that by 4. So X is 65. Does that make sense? Should there be more girls than boys?
I think so.
Why?
It says 65 girls and 52 boys.
Right, what about this problem tells us that there should be more girls? Right.
Because the girls' ratio is more than the boys.
Absolutely. At the very beginning, that ratio, there was more girls than boys. So in the end, there should be more girls than boys. Probably because girls are better. For sure. I don't know what you boys think you're talking about, but I know for sure that the girls are probably better.
Why do you say that?
It's obvious girls are always better.
That's false.
Just saying.
That's my opinion.
All of these girls in here would agree with me.
And
See?
all the boys are
And you boys are a little bit outnumbered, I think. 1, 2, 3, 4, 5, 6, 7, 8,
Oh, it's
9
not.
girls. 1, 2, 3, 4, 5, 6. Sorry, you're outnumbered.
Yeah, we
You
can do
lose.
a tug of war.
You lose, we
Yeah,
win.
you could have put boys in the class.
Okay, last problem. A banana slug travels 4.5 inches in 120 minutes. At this rate of speed, how long would it take the slug to travel 12 inches? Okay, what are we comparing? What is this problem talking about? Savannah, go ahead.
Inches and minutes.
Good. It's traveling, I'm going to do a different color, 4.5 inches in 120 minutes. So we're comparing the inches to the minutes. Okay? You guys, when you're setting up word problems, I can't force you to write down what you're comparing in those words, but it is extremely helpful to do that. Okay? We have 4.5 inches over 120 minutes. Yeah, that's slow, right? 120 minutes is like 2 hours. I traveled 4.5 inches. Well, that is about the speed of some of you.
Only
Yeah,
more
the girls.
Okay. How long would it take the slug to travel 12 inches? Where should I put the number 12? Right.
on top.
On top. Inches are on the top. So 12 goes on the top. We're going to put X on the bottom. That's what we're trying to find. How do we solve this? Go ahead, Riley.
120 times 12 and then divide that by 4.5.
Okay, multiply the numbers on the diagonal. 120 times 12 is 1,440. And then divide by 4.5.
Oh, big number.
And we get 320 minutes. Okay, which, yeah, it should take longer than 120 for sure. Okay, 4.5 inches for 120. So it's going to be a bigger number. Okay, questions there? Any questions from anybody on that? Okay, so at this point,